Hello, couple people hanging out with me today. How are we all doing? Good? Hopefully we're good. Hi, my name is Mark Mandel. I'm a developer advocate for Google Cloud Platform working on games. Today we're going to continue working on Agones, which is a project for running game servers on a project called Kubernetes. If you want to read more about those particular projects, you can go just down below the stream. There's a whole bunch of links there pointing stuff out. But it's basically open source on top of open source, which is cool. I am still sick a little, but I have a cup of tea today. So hopefully that'll stop me cut down the amount of coughing that I'm doing. So when we did our last stream, we worked a bit on fleets. So we're setting up an array of warm game servers for running dedicated game servers at scale. But today, I think what we'll like to do is actually probably round out the first pull request for this. So this should be kind of fun. And I've done a bit of work between then and now. So we've got a couple of things still left over to get done, but it's looking pretty good. So I'm just trying to think. Okay, let's go to code view. Let's do that and actually see what we've got going on here. All right, cool. Why don't we start with actually me showing you what's currently happening at the moment. So where are we? I will have a look in examples. Here we go. Game server set. No, game server set. I apologize. Fleet. Here we go. Okay, so this is an example where I have a really simple game server. I put up air quotes, wherein I'm basically just doing some UDP traffic, and just to test that everything works. And I just want to create a warm fleet of 2 of them. So we can actually this works right now, which is actually really, really cool. So I'm just trying to think. Actually, how do I want to do this? All right, we're gonna build this first. So I've got some make target and minikube. All right, so that's gonna take a little while. I'll have that run in the background while that's building and installing. We've got a couple of to-dos still left here, but why don't we have a look at what's going on? So the fleet gets created. We did a whole bunch of stuff. There's a backing resource called game server sets, which is basically responsible for having a certain number of game servers. That's all working. I'm just trying to think. Yeah, I'm just going to wait for this to load up, which might hopefully not take too long in the background. So while we're doing that, why don't we look at this? Okay, so okay, so one of the things we will need to do is, let's think this through. I'm trying not to edit code while it's compiling. So this is fine. Okay, let's come up here. Let's come up here and we'll talk through this for a bit here. So we'll see a little bug when we actually run a demo. Here we have this section here, which is basically an event handler. So we can intercept when a fleet gets created or when it gets updated, and we can enqueue it. So we put it in a queue that we can actually do some stuff with, and that's quite handy. We are only currently doing it when a fleet gets created or updated. That's all we're doing. We're not doing it in any other times, and that's not terrible. It's a good place to start. Let's see how this is going. Cool, this is getting there. Excellent. But the backing object behind a fleet is a thing called a game server set, which is just an object that creates game servers. That's really all it does. So a certain number. And we're not tracking for updates on that. So we'll have a look and see why that matters in a second. So why that matters is if we have a look actually at, so inside Kubernetes, if you're creating your own custom resource definitions, they usually go in here, package API stable. This is actually up here. This is all the generation annotations that you'll need to put in place if you're creating your own custom resource definitions. So those things need to exist. But we'll see here we have a fleet. We have a spec for the fleet. So like, what does that definition look like? So we saw this before. Here we have a name. Here's our spec. So we want 2 replicas of this particular game server image here that runs on port 7254 or 7654. Cool. And then our code will go through, create that, and then all the way down the bottom of the jar, which is an Australian reference that not many people may not necessarily get. We're going to count up the status values of the number of replicas that exist on both the game server sets as they get created or they get edited. And so we can count up the values, and we'll see that in a minute once this is done. Oh my God, this is taking forever. Apparently running OBS and trying to compile code at the same time is not the funnest thing in the world. I should have done this before I started my stream. Here we go. We're almost there. So we can actually run a demo and we can show you what it is that I'm talking about, and it'll actually make a bit more sense and be a little bit more exciting. Okay. Here we go. This is loading up. Lovely. This is loading up. So I've got a little Minikube cluster running locally. So sweet, that's all there. All right, let's have a look. So we can have a look at the logs for this controller that we created, which is basically it. No, what have I done? Let's try that. There we go. Okay. And so controller is the job inside Kubernetes that actually manages everything that's happening inside it. And that's all running. That looks good. All right, sweet. So I'll show you what this does. So if I kubectl, just make sure there aren't any fleets still lying around. Oh, there are. All right, so let's actually delete that. I'm going to delete it and create a new one so we can actually see what's going on. All right, so kubectl get fleet, or I could say fleet, doesn't actually matter. That's fine. Cool. All right, so kubectl apply-f examples. Where are we? Simple UDP server fleet. Excellent. So that creates a fleet, which is super cool. So we can do a thing called describe, which will give us a bit more information. Fleet, simple UDP. And we get to see some stuff, which is kind of neat. We see that it has a name, when it was created, various different values that we've had set up here, including what image it is. We can see that we have replicas too. Down here, you can start to see some of the status values. So this is what we were talking about before. Ready replicas is 2. Excuse me. Replicas is 2. So ready replicas is just a state. So when servers come up, there's an SDK in them. And if something goes correctly, then it says it's ready. So we're like good to go. So that's awesome. And then we, whatchamacallit, then we can go ahead and do stuff based on that, which is also nice. So, all right, let's move on from there. So, okay, so this is cool. You can see we have some events right down the bottom too. You can see that it's tracked that. So what we can do now, which is kind of neat. So if we say get pods, it's actually an easier way of doing it, but that's fine. Cool. So we can, or if we get game servers, which is actually what powers the pods, we see we have 2, which is what we wanted, right? And that's the cool thing. So now, say we want to have 5. So kubectl, actually I can just write apply. Let's run that. Simple UDP configured. So now if I get game servers, or I'll say game servers just to be there, I can see that I have 5 of them, right? And that's really cool, right? So I can scale these things up and down now, which is really handy, which is super cool. And I can scale them up, I can scale them down, I can see the pods that back them, that's all fine. But if I describe my fleet, you'll see these numbers aren't quite right here. So you can see status, that's like 2 when it should be 5. Replicas are 5. It's just a bit odd. Eventually this will actually sync up and get right, but it's not quite right. Even though we can see that we have an event here that we scaled up to 5, right? That's good. So we can fix that. It's not actually a big deal. We can totally fix it. So why don't we go ahead and do that? So I'm just making sure no one has pinged me on my phone, which is good. No one has. Excellent. All right, good. All right, so let's make sure that that gets updated. So let's go to our control. So we've got this update fleet status that does the work and just basically adds up the number of replicas that it has. Now, the actual thing that powers the fleet, and we'll have a look at that actually. We can go fleet, where are we? kubectl get game server set. So the game server set, its job is literally just to create those pools of servers. And there's reasons for that. When we get into like doing migrations or deploys, they become really important. But they're already set up so that they can get the replicas, which is nice. But what we will want to do is whenever, so actually, hold on, I'll backtrack for a sec. So part of syncing, this is an important bit. So part of so actually, let me start this from the top. So when we get an event for a fleet, it gets put into a queue, right? And so add or update. And what we do when the queue runs, its job is to run this syncer function. And basically the syncer function's job is to make sure everything goes back to a healthy state, or what's a declared state. So what will happen in here is the syncer will start, it'll actually grab, right? It'll grab any game servers that exist or game server sets, I should say, for that fleet. If there isn't a set created, it will create one. If there is one created and the number of replicas that are wanted on the fleet don't match the number of replicas that are wanted on the game server set that's behind it, then let's change it, update the game server set, and then it'll go on and do its thing, which is cool. Except that means then that when that updates, those values for the game server set don't necessarily end up down here, because I'm just getting a list of the game server sets, and they may not be updated yet. They may not have come through the system, or they may not have done the work yet, right? It's a whole queuing system. Everything is fairly asynchronous because things can fail. And so we want that. So there's a really easy way we can fix this. The easy way to fix this is, where are we? Here we go. Is basically to add tracking so that when game server sets get updated, we can enqueue the owning, the owning fleet, if there is one, which there may or may not be. And then the sync will just pick up and continue on where it's going on. So let's do that. That sounds like fun. I have a similar-ish example, but I'm just thinking about how I want to do it. Okay, so let's write this out. So GS set informer, there we go. Add event handler, so that's that. Now, there's some nice handler funcs. This is a nice utility method for Kubernetes. You'll see that there's several, like I can add on update, on add, or delete, but I only have to implement the ones that I want. So in this case, I really only care about update. It's going to say update func. Now the func is going to take two objects. It's going to be the new and the old. I don't actually care about the old one, so we're just going to take the new one. And there we go. Now, I'm going to need to do some work at this point. There's some work I need to do here, which is basically to, I need to look at the game server set and decide whether it has an owner, and if it has an owner, then do something with the owner, with the owning fleet, and put that in the queue. So let's do I think enqueue game server set. We'll call it new object. I think that's the way. So I just want to have a look at how I did it over here in the game server set. I'm doing the very similar thing all over again, and I just want to, no, I called it game server, you called it an event handler. Okay, then that works too. Because I'm not, okay, that's fine. I just want to be consistent in my naming. All right, so I'm actually casting here as well. Oh, that's good. Actually, you know what? I'm just going to copy this so that I do a couple of smart things in here. So let's do that. So we're going to steal some ideas here. Excuse me. So game server set. Let's get that in the queue. That's cool. Now here's a fun bit that's worth actually noting to make sure, and I would have forgotten if I hadn't thought about it. So there's always a possibility that something has been deleted inside Kubernetes, but the resource hasn't necessarily gone away. And when that happens, the deletion timestamp is, actually that's a better way of doing it. That's a nicer way of doing it. But basically the deletion timestamp is 0, then it's still fine, but that's what I want. So if it's, oh my God, I'm really having struggle with words today. So let's try this again. So if an object's been deleted, its deletion timestamp will be set. And it may be some time before it's actually removed from the backing storage that sits inside Kubernetes. So deletion timestamp is a great way of saying, okay, let me check your value. And if your value isn't 0, then you're currently being deleted. And I probably don't care about you at this point. So that's pretty good. Now let me actually think this through for a minute as well. Do I care about when these things get added or removed? For right now, I do not. Probably in the future I will, as there are considerations. I will probably have multiple game server sets per deployment, but right now I don't care. So I'm not going to worry about it right now. Keep things simple. I like to keep things simple. All right, so ignore it being deleted. All right, so game server set event handler. Let's see if this will let me create this method, which it will. Cool. GS set. IntelliJ is usually pretty good at creating the functions that I need, which makes me pretty happy. I'm actually going to move this, though, a little closer to the top. After run, yeah, sort of in queuing here. All right, cool. And game server set, where are we? Event handler, in queues, the fleet control, the owning fleet for this game server set, assuming that it has one. Cool. So I've done similar things over here. So actually I'm going to look at how I did it over here, because obviously I was smarter in a past life than I am now. That's interesting. Why did I double cast that? Let's have a look. Game server, event handler, stable, game server, boom, boom, boom. Oh, that's fun. Yeah, that actually makes more sense rather than doing it at the top. Well, it looks like I double dipped it. Okay, that's fine. Let's do that. That's actually nicer. I like that better. We should go. I should go back and clean that up. That's nicer because it makes it easier for this to be reused. So then new object is what I want, and then that can go away, and this makes that a bit easier. Oh, that's why I did it, because I wanted to check that. Okay, then that works. That's fine. In which case, we'll leave it alone. We'll leave it alone, and if it becomes a problem, we'll fix it later on. Okay, that's a minor issue. Okay, so if you've been on here before, I've talked about this. That's not the words I want. In queues. There we go. Resources inside Kubernetes can own each other. So if you've used Kubernetes before, you may have created, say, a deployment, which has then created pods. You'll find that that deployment is a controller of those pods behind the scenes. And that's why when you delete the deployment, the pods get deleted from behind the scenes as well. And we can do similar things within our own custom resource definitions as we create them. So when I create a game server set from a fleet, and then the game servers, you get this hierarchy of owning objects, which is really nice. And there's a lot of capabilities here that I can just take advantage of. So first thing I want to do is check to see if there's a controller. So let's do, actually, yeah, we'll go, I can grab it from here. I can basically cheat a little. So GS set, because that comes through. All right, so this says get the controller of it. If there isn't a controller, or actually get the reference to the controller. That's actually a very good point. And if there isn't one, then we don't care, which is fine. Yeah, I'm gonna steal this stuff again and then adjust it because it's really straight. It's really easy for me to do. So here I'm gonna grab the fleet, and we want a fleet lister, right? So I want you to go to the cache and I want to get me that fleet. Now the assumption we can definitely make, and the assumption that we're going to have, we always have across all this stuff for across Agones, is that objects that live in the hierarchy all live in the same namespace. That never changes and should never change. So we can grab the fleets for the namespace and then get the ref, which is in here. If you actually care at all, it's actually kind of interesting. Owner ref, here we go, has a name. And has whether or not it's a controller and a bunch of other stuff. So actually, this is interesting if you actually care. This line here. Currently, an owning object must be in the same namespace. There actually isn't necessarily an Agones thing. It's actually a Kubernetes thing. They insist that they are in the same namespace. You can't do ownership across namespaces. Okay. Sweet. So we grab the fleet. We check to see if an error is nil. Now there is one small thing we do need to do, which is it's possible that the object is no longer exists, or possibly it's been deleted, or weird stuff happened. Who knows? So if it's not found, we'll just log a quick reference. Owner fleet is no longer available for syncing, so we don't care about that. Otherwise, something bad has happened. So we're going to run handle error. That's not that. We want the fleet. Let's get the ref, error treating, game server set owner. And then we want to include the fleet. Cool. That should work. So I'm just going to write a little to do, just so I remember, write a test for this, which we can do, and I'll probably step through it in a sec. So let's run that, and then while that's running, we'll run a test in the background, so we can have that run. And we'll see if this actually works. better to have that run in the background. All right. So while that's going on, how do we test this? I've got a test here that actually checks to see for exactly this, for checking to see the event handlers are doing, or basically are hooked up. So we're gonna do that. So fleets. Let's go into fleets. Controller test. Let's have a look. Controller run. That's the one. Cool. All right. So if you haven't looked at this stuff before, Kubernetes comes with this nice reactor pattern for mocking out things, and also these fake watches for where are we? Where's a fake watch? I know we've got some somewhere. Here we go. Here we go. Fake watch that you can use to fake events happening. So like something gets created, something gets deleted, something gets done, or something gets updated. So we're gonna need a new game server set watch so that we can fake when things come in, when game server sets get updated. Game server sets. Now, always remember when you're doing things with Kubernetes and you're naming a resource, it's in plural. This is the trick. So there's that. Let's actually make sure that's hooked up. GS set watch. Beautiful. Okay, so that's all there. So what we've done is we've actually set up these watches. We've replaced what would normally be that sync handler with just a channel that we can shove stuff into. Because this stuff is asynchronous, it makes things easy. We start our informers. So starting the informers fires off the caching system that runs in client Go, so that gets going. We fire off run, and then we start doing. Here's some trickery here. So basically, F is my function for grabbing values out of that received channel. But if it fails for whatever reason, there's no value there, it times out after 3 seconds. So I know that a failure actually occurs. Afraid Duchess, I did not see you ask a question. Let's see what you had to say. General question. When you're starting to build something like Agones, how do you know where to start and where to go once you've started? That's a good question. So I started with first how I wanted to lay out my project. And how I wanted my build tools to work. That was the first thing I wanted to get going. I wanted to make sure that I had a really good set of build tools and development system works. So you may have noticed a lot of the stuff that I've got running is like Make. It's all powered by Docker. I really wanted to build a build and test and development system that was all either just Make and Docker. Those are the two things. Those are the only dependencies you needed. And there was that. And I also had a very simple roadmap for what I wanted in my first version. So I'd already decided, okay, I just want you to be able to run a game server. That's it. A singular game server, nothing more complicated than that. And then you start layering, right? You start saying, okay, what are my next features? What's my next thing? What's my next feature on top of that? So give yourself small milestones and try not to eat the whole apple in one whole bite. I find works pretty well. So to your actual question as well, since we're talking about it, we have milestones here in Agones and trying to keep them relatively small. It's smallish. I think we have a couple of things here. I mean, game server fleets are a chunky piece of work. But we're looking at game server fleets, we're looking at YAML packaging, and we're also looking at C++ stuff. So there's actually 3 bigger things there, but we've got a lot of contributors. Or not a lot, I shouldn't say a lot. We've got several contributors which are working towards this stuff right now. And so it's actually been a nice goal. And then we just kind of roll through, yeah. As the community asks for more stuff, then we get that to happen. Okay, so all right, so I set this up. Here's this. So I have an F, so I can actually see, did a value get pushed in to that channel when it should have done, like when that works. So okay, what we want to do is test update game server set. Let's think about this for a sec. Yeah, this may or may not work. Let's actually see how it goes. So what I need is a game server set. So actually I can get one straight out of just set equals fleet dot game server set. Yeah, game server set. Give me that. I'm gonna actually set the name, because it'll come back with a generated name otherwise, which I don't want. And generated name equals blank. All right, so that's giving it a name. See whether this works. I'm actually curious to see if the testing system will actually let me fire an update event on a game server that hasn't necessarily been added before. I forget. I feel like I've done this before, but I think it may. Just at watch. But let's find out. Modify. See what happens. See what happens. See what happens. All right. Test controller run. Let's run that. And see how we go. I have a feeling it's going to fail. It is going to fail. Yep, I thought it might. Yep, it failed there. A test here. Yep, so that's going to fail. Okay, and that's not surprising. And I'll tell you why that's not surprising. It's because the informers behind the scenes for what runs, what are called informers, they have a cache. And so if it hasn't seen it before, it probably doesn't know it exists. So in which case, gset watch.add gset. Let's add it first, which should put it in the cache, and then we can modify it. So gset, let's just change the value. We'll change one value. Spec.replicas equals, or plus equals. Okay. That's better. All right, let's try that now. So I'll hit the hotkey to recompile and run that test. Spinning, 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 spinning. Test pass. Awesome. Okay, so that looks like that was doing exactly what we expected to. Let's actually look at it as it was deployed. There we go. That looks like that's up there. So kubectl, let's just namespace Agones. I just like to check the logs. And that all looks pretty good. So that looks like I didn't get any bugs or anything. So let's see if that actually worked this time. Where are we? Do I still have a fleet there? I do. Yeah, let's delete the fleet. We'll start fresh. It should, in theory, it should actually still work. Just because we changed the controller over, so it should have updated it. But let's have a look. So, all right. So let's apply the fleet. And let's describe this fleet. Sorry, simple UDP. Have a look. Okay, ready replicas is currently 0. There's 5 of them running. Why? Ooh, we have a bug. I've done something bad. What have I done? I don't know. That's really interesting. So what has that done? Oh, that's really interesting. kubectl. All right, so let's describe the game server set behind it. So that's got the right numbers. Replicas equals 5. Ready replicas equals 5. That looks correct. Okay. So those values should come through to the fleet. But when we look at the fleet, Oh, now it's up to date. That is super weird. Why would that have happened? Well, let's have a look at the logs. Let's see if the logs shed any. There are going to be a lot of logs, but let's have a quick look and see if anything immediately jumps out. This looks like a lot of text, but it doesn't look like. That looks like weird stuff from Minikube. So I'm gonna ignore that for now. Unable to decode event from watch stream. No kind fleet is registered. Don't know what that is. Okay, I'm not gonna worry about that too much because sometimes Minikube throws up some weird errors. So I'm just gonna ignore that for now. Okay. That's an interesting one. All right, so this actually leads us into another place, which is actually kind of good. So let's actually go there first, which is the fact that my update function for those statuses doesn't have any tests. So let's write some tests and see if that solves our problem. If we can't see anything immediately in the code, I'm just gonna git add and then git commit and then we can where are we? Track updates on game server sets in the fleet controller. Cool. Alrighty. That's fun. Alright, so that's a good start. So I've written a test for that. I can actually get rid of that. So that's actually hooked up. So let's look at our function here. So what do we do in this function? So we have this update fleet status at the end of when we do our syncing of a fleet. And what do we do from there? So we list game server sets for the fleet. We assume that's correct. That's been tested. It seems to be fine. We set the values to 0. Then we loop around the lists and we plus equals replicas. We make a copy first. That's important. Again, caching. So you want to actually make a copy when you do this stuff. And oh, excuse me, my dog is sitting next to me and she's making it a rather smelly environment. Dog's the best. So we running around our list of game server sets. This looks like, how could this end up being 0? All right, so there we go. And then we update it. And if there's an error, we return it, which would then get passed up here. Okay, so this seems fine, at least at face value. But let's try this. Let's see what we can do here. Thinking. All right, so we need to write a test for this. Yep, somebody came home, which means my dog's gonna bark at stuff. There she goes. All right, so let's pop up over here. All right, and let's write a test. Cool. Controller update fleet status. So I'm gonna need a couple of things that I've written before. That looks like a good start. So default fixture gives me just a standard fleet that I've been using across all my tests. New fake controller gives me a controller that is powered by a whole bunch of mocks that I can then intercept and do stuff with, which we'll play with in a second. Cool. Suki, come here. Sweet. All right. And so first thing we need to do is populate the cache. So let's do that. I'm going to grab not the sync handler. Here we go. That's what I want. Poof. Okay, so in between here, basically I need to have a couple of game servers. So, or game server sets, I should say. So do I have this anywhere else where I have a list that I can steal? There's one, but I need to create some game server sets. Okay, you know what? I'm gonna do this by hand. It'll be easier. All right. I want to game GS set 1 will be fleet.gameserverset GS set 1 dot object meta dot name. I need to give it a name. Equals GS set set 1. And that's fine. GS set 2 2 equals fleet dot game server set. And then we'll do the same thing. GS set 2 dot object meta dot name equals GS set 2. Okay. So I have 2 of those. I will say GS set 2 dot status. We need to set some status values actually on both of them. So let's do that. Status dot replicas equals 3, and we'll set some arbitrary values. And ready replicas, which is number of ready servers we have, that can be 2. Cool. So we're assuming, say, a situation where we haven't yet fired up all the replicas yet. All right, so they're not all ready to go. They're taking some time. We'll do the same thing here. Replicas will be 5. We'll say this one's ready. This one's ready. It's got everything here. All right, cool. So to get this in the cache, there's a couple of ways. We're just going to do a listing on a mock, which the informer will go intercept. We won't have to worry about it, which is nice. So mocks Agones client dot add reactor. So adding reactor is the way of basically saying, hey, pretend like when this method gets called, we want this thing to happen, is really what it boils down to. Nothing more complicated than that. So when I say list game server sets, what I want you to return is these values. So here comes an action. Ooh, it scrolls over nicely. Let's drop that down to the next line. And so I'm going to return a true to say don't process anymore. Game server set list, which actually I want a reference to that. And nil is the error that we'll return. And then we'll put in dereference gset1 and dereference gset2. All right, so that'll put it into the cache, except for the fact that that should be items. That's better. Nice. It is complaining at me for, I don't know why. Why is it complaining at me? Missing return. Oh. That would do it. That's a bit better. Oh, no. Items is an array. Game server set. There we go. Oh my god. Okay, we got through all the type systems. We're all good. Okay. All right. That gives me a stop channel, which I don't care about. All right. Sweet. Okay, so that starts our informers. Cancel will actually shut everything down once we're done. So sweet. All right. So now we can actually do our work. Really, this should be a pretty straightforward test. So c dot. Ooh. No, it's not. And I'll tell you why it's not. Because we do that, which is great. And we get an error. We'll want to check if that's nil or not. Which is fine. So that's all good. But we need to intercept when the update happens so that when this runs, we will know what's going on. So yeah, let's do that first because that's more fun. So really, all we need to do is have us another reactor. Raise client dot add reactor update game server sets. It's a really nice pattern that they built here. I'm really quite a fan actually. Boom, boom, boom. Alrighty. So I need to get the value out. We did this in the last stream, but we'll do it again because we have to. We have no choice. What I want is an update action. So the action that comes through could be a variety of types. We know this is an update. So we can take action and cast it to an update action. So we do that first. And then we want a game server set. So the update action has an object, which is a pointer to a game server set because we know what's coming through. And then finally, just make sure that nothing breaks because I've done this before. We want to pass that back out again because usually an update returns a value and we want to continue from there. So that's fun. Okay. All right. So now we want to do some assertions. Sweet. except for the fact that I did the wrong thing. What we actually want to do is check the update on a fleet, not in a game server. So that's better. That's better. Okay, now we're getting somewhere. Okay, so we can now test values. All right, so let's do assert equals t. So gs set to dot spec dot no, not spec, status, my bad, dot replicas plus gs set. Actually, I might do that in numerical order. It's a bit better. Gs set 1 dot status dot replicas plus should equal the fleet dot spec status. Oh my god, dot replicas. And then if we are here, ready replicas, that should also be true, is what should happen in there. So because those values should add up once we've done all the work. All right, let's run it, see if that works. All right, so that test passes, which is good, except for one small problem. I still don't know why we ended up getting 0. That kind of freaks me out a little. Thinking. Ooh, I think I know why. I think I actually know why this failed. And the reason that it failed is because we actually have the wrong events. So hold on, let me commit this. Actually, let me go in here. I think I still have it to do. Yep. All right. So git commit test for update fleet status. Whoop. Oh. Actually, since I'm here, let's actually format that. Cool. Oops. Blah. All right. We add everything. All right, and then we'll just amend it to the last commit. All right, so that's there. All right, cool. So I think I know what's going wrong, and I think why we got 0 is why this happened. So let's have a look at our controller, and let's think about our life cycle here. So when you create a fleet, it's going to create a game server set, which is cool, and that's nice. Except for the fact that the only event we're currently picking up on is that is the update func. All right, so Brave Cobra 2 GS set 2 replicas is set twice. Let's have a look. Was that in the test? That must have been in the test. Let's have a look. Oh, you are correct. Thank you. Let's fix our test. Thank you. Well spotted. Let's run that test again. It still works because the default would be 0, but cool. Awesome. Thank you. Cool. All right, let's... Thank you. Whoops. Git commit amend. There we go. Put that in there. Awesome. Thank you very much, Brave Cobra 2. Much appreciated. Okay, back to the topic of what I was working on. So when it creates the new one, we also want this to happen. This is like super important. The good news is this is actually really easy to do at this point because we can say add func as well, and then we can use the fact that herein becomes an issue. All right, so what I'd like to do at this point is use the fact that Go has first-class functions, which is nice. So I can actually set the function to be the add func handler, except that I can't. And the reason I can't is because the type signatures don't add up. If we have a look here, add func takes a function of option interface, except here we have game server set handler takes an object of type game server set. So let's change that. GS set equals object dot cast. And that'll panic if something terrible happens, and I'm okay with that because it should never come in here anyway. Okay, so now if I scroll back up to the top, boom, 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 add func, game server sent. Okay, that's all looking pretty happy. And we can actually go into our test too, and let's do that because I like testing things before I run them. Well, actually, since we'll do the same trick we did last time, which was push the fix up. Push the fix up. Do I have any tea left? I do, good. And while that's working in the background, let's fix it. Ooh, and this will actually work really well because we've already done this work. So really all we need to do is actually drop in an equals here to make sure that that thing's actually been pushed in the queue and that we're good to go because we already did the add, so that's in the cache. So most of the work is already done. So test controller run. Let's run that and away we go. It's really funny. I think about like 2 hours ago or this morning, I was like, yeah, I'm going to have this done well before I want to stream this afternoon. And then you start digging into stuff and you're like, oh, there's all these edge cases that I really should take care of. But I think that there is exactly why we got 0. Because when a replica set starts up, when a fleet starts up, those status values are set to what is the 0 value for Go, which is 0 for an integer. And so that's just going to come through. Now, there happen to be some details from other, like there's a bit of a race condition happening so that some details got set, but some didn't. And so that's why these things actually worked in that case. But we don't want to rely on race conditions. Race conditions are bad. Okay, so that's kicking through. That test looks pretty good, so I'm kind of happy about that. I think this will be pretty good. Let's just, while that's going on, I'm just going to have a look and see if there are any wayward to-dos lying around. Nope, this is a to-do that's actually lying around from, whatchamacallit, from some generated code. So I actually don't care about that. So usually, actually, when I code, and I do this a lot, I write a lot of to-dos when I can sit down and think for about an hour or so, and so that I have a really good plan on how to do stuff. Come on, compile. I might have to change this right now. It cross compiles for both Windows and Linux and Mac for something that I don't actually need all the different versions for. But it's coming. It's working. It's working its way through. But I think that's going to solve our problem. While that's going on, actually, kubectl get fleet. Yep. I am not going to start deleting that while stuff is happening in the background because sometimes weird things happen. So I'll wait for that to come up and then we'll play with it. And we'll recreate it, which will be fun. Okay. What exciting things can I tell you in the meantime? Let's have a look. Can we talk about panicking real quick? Oh, that's a really good one. So let's talk about that. So panicking. So Go doesn't have exceptions, Afraid Duchess. Thanks for the good question. So it doesn't have exceptions. So you'll see everywhere, right? Returning errors, return error, and that's totally okay. That's what we want. Those are sort of runtime errors and things that are manageable. Now, panics happen when like pretty much catastrophic stuff happens, and they will get passed up the chain, and you can catch them and do stuff with them. Although usually, often it's the sort of thing that you don't really want to catch because it's like, okay, something really horrible happened. So you're probably better off maybe restarting your whole system or doing something like that, which is actually what I have set up here. So when we were looking at, say this, for example, right? So this cast here, if it can't cast here, right, then it can panic. Now, I could actually write this cast in a way that it could check. It's like if it's not of this type, return me a Boolean and the value, and I can check the Boolean and see whether or not that works the way I want it to. But in this particular instance, if somehow a game server set, something other than a game server set ends up in this code, that's like extremely bad, and I definitely don't want that to happen. So I'd much rather it panic and I have to go do something about it than not. Yeah, panics are not things you want inside your code, right? Don't use those for like flow control or anything like that. Don't think of them as exceptions. That's not accurate. I would think of errors-ish like exceptions. Panics are like seriously catastrophic stuff. Awesome. Okay, so that's installed. So I'm going to delete my old fleet. Fleet. Oh, bye-bye. So here's an interesting thing. We'll actually see like all the pods They're all terminating now. And that's actually that whole controller chain we were talking about before. Kubernetes just does that automatically. It's got some nice garbage collection in there, which is super sweet. All right. Let's make this big. What's going on here? What happened? Uh-oh, I did something weird. All right, in which case, let's bring that back and bring that back and shrink it and make it bigger. There we go. Lovely. One day I'll work out what that shortcut is that finds out that does that. All right, sweet. So kubectl get fleets. Oh, fleets isn't a thing. Fleet is a thing. So that's not there. All right, so let's apply it again. Hopefully. So describe our fleet. Oh, here's a really small thing though. When I say describe fleet, it actually describes all the fleets, but because I know that I only have one, I can do that as a nice thing. There we go. Sweet. So that says ready replicas equals 5, replicas equals 5. That looks pretty good. So let's scale this down. That's actually going to take a little bit longer. Scaling up a little bit faster, but let's just do it. That'll be fun. So let's take it back down to 2. So that's looking like that should be working the way it should be working. Excellent. kubectl, let's just run that apply command again. So if we now describe our fleet, here we go. So replicas equals 2. Ready replicas is still 5. Interesting. So we've got drop that down to 2. If we look at our pods, we can see 3 are terminating, so that's good. If we look at the backing, describe, where are we? Describe game server sets, GS sets. Of course, there's one of those. We can see that those have been deleted. Ready replicas are 2, replicas are 2. So that's actually an interesting question. Describe fleet. That should be down to 2. And it is. All right, sweet. So that all looks like that whole chain of things is all working the way it should do, which is actually really awesome because that's exactly where I wanted to land for completing this pull request, which is really cool. That's awesome. So why don't we'll scale up 2 just for just for things and giggles. Let's go up to 4. And if you're not familiar with Kubernetes as well, it's kind of worth noting, like all this stuff I'm doing through kubectl, I can also do through the API. Like all the hooks here are available through the API. So another interesting thing I'll also mention in here. Actually, I'll do that because that's faster. If you're familiar with Kubernetes, you might be familiar with something like stateful sets or deployments, and you might be looking at this and thinking, this looks exactly the same. Why should I care? Which is fair enough, and I get that. But there's some special lifecycle management in here that is very specific to game servers. That means that we can't use that many those types, I should say, those things. And the reason we can't use those things is for things like, okay, if we have a fleet of game servers, for example, and then you allocate one out of that fleet, and some people are playing on that game. You can't delete that fleet. Like you can't delete that. Sorry, you can delete the fleet. Sorry, you can't delete that game server while it's running. This is actually really important, right? Because you have players playing a game, and that's bad. So if down the line, when you want to say update a new version of the server, and you push that out, normally for something like a deployment, you would do a rolling update, and that would just slowly delete all the pods that were currently running whatever that thing was, and it would be fine as long as your application is stateless and doesn't care. We have state here and we have direct connections, so we can't do that. So we need to be very particular about what we delete and how we delete it. So we need our own tooling to be able to do this stuff. So this is why we're building out all these things. So this is interesting. Just having a look here. So we got ready replicas equals 4, but replicas equals 5. I wonder why that is. Let's have a look. So let's have a look. Let's describe our game server set. Oh, that's all lowercase. That's better. So you're saying the same thing. So let's look at game servers. Let's just basically go down the thing. So we can see we have 5 of them. All right, so that's interesting. So let's look at our pods. I wonder if one's of them terminating. There we go, one of them's terminating. So it's just taking a little bit longer to come through, but that seems to be working quite nicely. Let's see. All right, that might be taking a little bit of time to come through. And something that this is kind of okay-ish, and you'll see it in deployments as well. Sometimes Kubernetes will overshoot a little bit. So my code does overshoot sometimes, just a touch. If certain game servers are to take a little while to start up, it might be like, oh, I don't have enough. I'm just going to keep starting things up until I get what I need. And so basically we come back to a happy place is really what it comes down to. Sweet. Now we're at 4. All right, cool. So in theory, everything should have updated and the event chain should go all the way up. So let's have a look if that has actually happened. And it has. Ready replicas equals 4 replicas. Beautiful. Super happy. All right. Awesome. I'm actually going to pop over here. So what we're going to do now, actually first we will go import /w package. Just make sure everything's formatted correctly. Okay. We're going to set our fleet back to 2. So basically I want to get this ready for pull request. We have a couple of minutes left. So let's do that. We'll do some fun some fun stuff to make that happen. All right, so let's git add -a, git commit. Solved problem with game server set events causing issues with fleet status. Cool. All right, so I'm going to push that up. It's going to go up to my local fork on GitHub, which is nice. And that means that I have a safe place to go back to if I mess this up. So what I want to do is a few things. One, the first thing I need to do is bring everything down to a single commit, because that'll be nicer for anyone who's reviewing it and also just seeing commit history. So we're going to do some rebasing for anyone's thinking about that for doing git type stuff. So if I have a look, this is GLG is git log with some extra stuff on it. Whoops, not that. GLG. There we go. And so we excuse me. We can see that's where the top of my feature branch is, which is where I'm working on. Feature fleet, no update. We can see that it lines up with my origin, which is where that's my local Git repository. And if we scroll down, we can see there's I've got a bunch of work in progress commits here to get that going, which is fine. But we're going to want to get that. You can see I'm trying to get this back to a happy place. I was doing all sorts of fun stuff. Here's some previous work. And here we can see where master is. So here, actually what's interesting is, so that's where master is locally, which lines up with upstream. So upstream is what I usually call a remote that... a remote that is where, what's the words I'm looking for? That's my dog Walker. My dog pretty much rolls my life. Go on, Suki, go have fun. Cool. So upstream is what I call the remote for where the original code comes from. So actually, let's look at that. We can actually, that's a pattern I really like. So you can see, so origin is github.com on Mark Mandel Agones, and then upstream is the Google Cloud Platform one, which is where the official one. And so it's really easy for me to say things like, just pull me down upstream, for example. So I can actually rebase this all in one go, but I try and do this in sections. So what does rebase mean? Basically, your Git history is as malleable as putty. And if you know the right tooling, you can do whatever you like to it. So I like to commit a lot with a lot of work in progress stuff that doesn't necessarily work, stuff that I'm just trying out to see what happens, knowing that I can go back and change things. So, 1, 2, 3, 4. So what I'm going to do is grbi is shortcut for git rebase -i, which is interactive. And head, I'm just going to take like the first, say 4 commits, and we're going to squash them together. So, all right. I'm going to end up rewording a lot of this. So I'm just going to go squash, and then this is just a lot of stuff. So S is squash, so that'll do use the commit, and it'll meld it into the previous one, so the one above it. But gives you the opportunity to rewrite the comment. F is just fix up, which is squash, but it's just getting rid of the comment, so we don't care about that. So let's do that. Yep. What have I done? Okay, cool. That's actually exactly what I wanted. All right, so you know what I'm going to do is I'm actually going to kill pretty much all of this. I'm going to write a proper commit message. If I pop over here, actually, for interest's sake, if you come into Agones, And I'll need a couple of things in here too, so we'll do that. There's a really great article that we have inside the contributing directory that's well worth reading. How to write a good git commit message. It's awesome. You should totally read it. All right, so actually while I'm here, I am working on fleets, which is this ticket here. So I want to make sure I reference that. It's number 70. All right, so I'm working on that. Creating a fleet creates a game server set. Actually, I can just take that as a title for my commit. So let's do that. Create, all right. This implements, what do I want to say? I want to say that this implements, this is the simplest. Yeah, what do I want to say? I want to say that, let me think about this before I write words. I want to say that all this is doing, anyway, let's do it that way. All this PR is doing is, actually I should say commit. Let's say commit is doing is create a game server set when a fleet is created. Also, if the replicas in a fleet are updated, then the game server set replicas are also updated. For this commit, we are not worrying about handling updates to the spec or image, for example, to the fleet, and doing updates to a live fleet. We are just concerned with scaling up and down. So I want to do those later, but I want those to be separate pull requests so that they can be smaller and people can do it. We'll say parent tickets. So there's a reference, and I think it's number 70. Yes, it is. All right. Creating a fleet creates a game server set. All this commit is doing is creating a game server set when a fleet is created. Also, if the replicas in a fleet are updated, then we'll say backing or owned is actually probably the game server set. Replicas are also updated. Updates to spec to the fleet and doing updates to a live fleet. We are just concerned with scaling up and down. All right, cool. That seems pretty good, actually. Sweet. So we still have a couple more commits to merge, but that's looking better already. Let's have a look. How many more have we got? All right, sweet. So what I can also do, which is a nice trick, I'm just going to go grbi because that's git rebase interactive, just handy. I can just say grbi master, and it'll take everything from master and rebase everything above it. So all I really want to do is take this commit and push it up. So I'm going to do that. So I will fix this one up. I'll squash this one because I want to keep it, and I'll end up removing this when I get to my my interactive screen. So let's do that. Here we go. So we'll delete that. And then we have this. That all looks good. Cool. That looks pretty good. All right, so we're gonna push that. All right, so we're actually git push dash f. That's a shortcut. Now I'm gonna have to dash f it because I'm gonna have to force it to overwrite the history. That is the dangerous part, but I'm feeling pretty comfortable about it. I do this a lot. Just have a quick look at the code. Everything looks pretty awesome, actually. Actually, I saw a small thing. Test add update of game server set. That's actually better language. So let's push that into there. Now let's push that up. Okay, cool. So we're rounding out at about an hour, and that's going up. So what I would do now is pretty much come over to here to Agones, see that, and then I can compare a pull request. I'm not going to do this just yet, and the reason I'm not going to do it just yet is what I like to do is basically go through my own changes and see what they are and see if there's anything that I might want to change all the way through here or anything I happen to have missed. So I'm going to do that probably after I get off this stream, and then I will commit it and you'll see the pull request show up. So yeah, I'm gonna shut things off here. Thank you very much for hanging out with me. I'll put the recording up on my YouTube channel that you can see at the bottom of the page just below the stream. And as usual, I am regularly streaming at 9 a.m. Tuesdays, but as you can see, I like to do some ad hoc stuff every so often. So if you want to pick up on those, then simply follow me here on Twitch or follow me on Twitter, and you'll get those notifications as soon as I'm able and available to do that kind of stuff. But yeah, thanks so much for joining me today. I appreciate you hanging around, and hopefully I will see you all again next time. Thanks so much.